touched on this yesterday, and this is the way you calculate how much the monthly payment formula will be on a loan that doesn't meet the criteria of our table. So not even thousands and not in that percent range by 25s. So I'm just going to put it up here, but it was on the notes from yesterday, so you should have this written down already, is the rate as a decimal. Hold on. Okay. T is time in years. Now you'll notice we don't have N anymore. Loans are compounded monthly. Pretty much across the board, that's standard. Most credit cards, loans, anything is compounded monthly. If there was a difference, they would have to point it out to you, like bring it to your attention, because you just generally assume it's monthly. And it would have to be in that promissory paperwork. So there's no N in this formula. P is the amount borrowed, so the total amount that you're borrowing. And this calculates how much your payment will be for each month. Okay, so now that I've written all over our problem and made it hard to read, here's our P. That's the total amount being borrowed, $28,716. And that happens, like if you're buying a car, your car is usually not some nice even 40,000, 20,000. It's some weird off number after they've gone through the negotiations of the trade-in value and the down payment, and then they try to tack on all the extras. Like, oh, you need the upgraded floor mats for $327.50. You know, they throw weird numbers in there, try to upgrade you. So they're not usually a nice even thousand. We have a 4-year loan, that's T, and an annual percentage rate of 5.2%. This is R, and we want to convert it. Okay, so I'm moving this decimal point 2 spaces. Next, I plug it all in. I have all of my data plugged into this formula, and now I need to do some calculations. Okay, we're going to use PEMDAS, so you're going to do parentheses first. Everything inside the parentheses is going to happen first. So the first thing I'm going to do is I'm going to divide 0.0512 by 12. Okay, and this is going to be replaced with 0.0042 and a repeating 6. So what I'll do with that repeating 6 actually is make it a 7. I'm going to go ahead and round. I have 3 of those. So I'm going to replace all 3 of them with a decimal. There's no 1 there. Okay. The next thing I'm going to do is the exponent. And what I'm going to do is I'm going to multiply the exponent. Second. 12 times 4 is 48. I have 2 of those. Okay. Then I'm going to add in the parentheses and raise to the exponent. Okay. So what I'll have is no room. So hold on, let me remove that. Okay, so I added 1 plus point 0 whatever. That's just 1 point 0 whatever. Now the next thing I do is I raise it to the exponent. So I take that and I raise it to the power of 48. Okay, so I did the exponent. That's how I got this number. Next, let's see what color we should use. Pink, okay. Next, multiply across the top. So 2, 8, we're just going to multiply all three of these things together across the top. I'm writing up the side, but that's just because I like to keep more decimal places. You don't have to do that. Baby blue. Then we subtract the bottom. Okay, so 1.226745015 minus 1 is just 0.226745015. I should probably kept that white, but. And finally, what color? For our last hurrah step. No, nobody has this? Okay, orange. Then you divide. That says then. So last we divide. So I'm going to divide 150, 0.420186, and I'm going to divide that by 0.226745015. And my payment is going to be $663.39. Now, this actually says 0.3891643. Do not write all that down. Have any of you ever paid less than a full penny for anything? So the second decimal place is the pennies, 9 pennies, 3 dimes, 9 pennies. You can't pay parts of pennies. So always round to just 2 decimal places when you're talking about money. Yes. Well, okay, finance a car for $98.71 for 5 years at 4.9%. So we've got our formula. No, we're just gonna do another example because I don't think that like one example on this formula is enough to make you comfortable with it.
Yeah, I understand. I just didn't think to look for blank page.
So we've got P, T, and R. So I'm going to plug all those in. You know, it's a lot of writing, but none of the math itself is very hard. You divide, add, exponent, multiply, divide, subtract in there too. It's not, there's no like logarithms or no variables. You know why? Here's why. Okay, so we're going to divide 0.049 by 12. And that that is 0.00408 repeating threes.
Holy crap.
I haven't put in the exponent yet because I'm going to do that next. Okay, so 12 times 5 is 60. So those are my exponents.
I think that's like the easiest 12 for me to remember.
Yeah. So I did this part and I did this part.
That too.
And then I also added. Next, I'm going to take and do my exponents. So this part won't change, this part won't change, but this part will. So I'm going to do plus 1, and I'm going to raise it to the power of 60. I'm going to get 1.2769841 minus 1. This number and this number will always be the same as you go through because you can see they're the same thing, right? Good, okay. Then I'm going to multiply the top. So 9871 and 0.004083. And I'm just keeping lots of decimal places because that's what I like to do. Because I like accuracy. Then I divide, finally, 0.2769841. So if you were financing this car for 5 years at 4.9% interest, you'd get 185.81 would be your payment.
That's how much I wanted to pay.
Me too.
But I didn't have established credit, so
What if I got
I'll take it.
185.82?
Close. Yeah. Now, we're making 60 payments, right?
60 payments.
Oops. Is the total we're paying. And if we subtract the original amount of the car, we're paying $1,277.65 in interest. We're taking out a $430,000 mortgage. Okay. For 30 years at 8%. Now this is not an uncommon, I mean, a mortgage is typically 15 or 30 years. It's 15, 25, or 30, sometimes 10. Okay. So we're going to use our monthly payment formula again. So we want $430,000. Our rate is 0.08 for the 8%. And we're doing 30 years. Okay. 0.08 divided by 12 gives me a long decimal because it's repeating. So it's 0.006, and I'm going to put 67 because it's 6 repeating. And then 12 times 30 is 360. So if you take out a 30-year mortgage, you're making 360 house payments.
360. That's a 30.
Okay. Next I do the exponents, and I'm going to get 10.9357296. Now, we haven't gotten anything more than a 1 with decimal, like 1 point stuff on these, and that's just because our exponent here is so high. It's so many payments. That's why we get the 10. Oops, that's too big. Next, I multiply the numerator. And I subtract the denominator. And then I divide. So the monthly mortgage payment on this loan would be $3,170.96
Monthly.
monthly. So this is monthly. Okay.
What kind of income would you have, or would you want to have?
Have a pretty good income with some savings.
Okay, they say that you should spend all right, we're paying $3170.96 per month. And we're paying this for 360 months.
Gosh, that's a lot. Is that a million?
So your $430,000 home
Cost
is going to cost you $1,145,000.
Did you round up in this one? Or not? Are you serious?
I'm not sure. Probably I dropped decimals. Now, that's the total of all the monthly payments. The finance charge you deduct your original $430,000 that you actually paid for the house. You're paying $700,000 in interest.
Right.
Almost double
What you?
the value of the house is being paid in interest. Yeah.
Banks just
I just
love
did
their
the
houses,
problem,
don't they?
and I didn't cut off any decimals when I was doing the problem, and I got 3,155.18.
Yeah. What for the payment?
And you said
Close
as
enough.
long as it's not off that far.
I'd have to look at what you entered and stuff, but like I said, it's rounding changes things, and we're talking big numbers at this point.
Yeah, that's what I'm saying, but the reason why I say this is, like, when we take the test, will you round or will you do it by the decimal?
Both.
Just to make sure?
Mhm.
Okay.
I do both. Okay, so which is greater? Answer D. The interest or the original cost of the home?
The interest.
The interest. The interest costs more than the house. Now, let's try something, okay? It's insane, right? Let's just try something really quickly. Let's see what happens if we take that same house at the same interest rate.
Should we please have another sheet of paper?
If you have room or if you want to. But instead of 30 years, let's do 15. Let's just see what happens if we cut the length of time in half. Okay, I'm going to go back and get my decimals because it's the same decimals, right? Except the difference is instead of being 360, it's 100. Whoops, 12 times 15. That's 180 for my exponent. So I'm going to do 0.08 divided by 12, and I'm going to raise that to 180. And instead of being 10 point whatever it was, it's now 3.0692147. Okay, subtracting 1 from that. In the denominator, yeah, where?
Oh no, you got it on the other side.
Here.
The 12 to the 15.
It's up here, 180. Oh, yeah, thank you. I forgot it there. Okay, now the payment goes up, which we figured it would. You're reducing the length of the loan, right? But the difference in the payments, what was our other payment?
3,170.
3170?
That's what I meant. And 96 cents.
It doesn't go up much if you think about it.
Yeah, you just
Well,
cut the
that
length
makes
of
it a
time in
little
half.
different.
It goes up $958.89.
That's worth it to cut the time in half.
Yeah, watch what happens to the interest.
That also takes the interest down with it too, though.
Yeah, so if I do 4129.85 times 180 payments, and if I take that and I subtract my original 430,000,
Doesn't seem like a big difference.
Yeah,
That's
it's
the
less than
interest.
less than half the amount of interest.
Right, that's what you, yeah.
Yeah, you're taking, instead of turning your $400,000 home into a $1.1 million home, you're turning your $400,000 home into a $700,000 home. Before we more than doubled the cost of the house.
Yeah.
Here we didn't even double it.
And what did you change?
I took the length of the loan in half.
Right.
So instead of doing a 30-year mortgage, I did a 15-year mortgage. Instead of doing a 30-year mortgage, if you can't afford the difference in payment between a 15 and a 30-year, do a 25-year or a 20-year. Do the shortest length of time that you can afford the payment on.
What happens if you pay off the mortgage before that time is up?
Depends. Remember we talked yesterday about, it was yesterday about the prepayment privilege and the prepayment penalty?
I didn't hear you say
Oh,
that.
okay. Yeah, there's prepayment privilege or prepayment penalty. It'll be in the promissory note, which is the contract of the loan. Some loans you can pay them off early, and that's when you have a prepayment privilege. But some loans, if you pay them off early, there's a penalty because they try to recoup that interest that they're going to lose.
Does that penalty get taken off of your credit score too, or
No, you have to pay it. It's money.
No, I mean like.
No.
Does that count on your credit score?
It doesn't count on your credit score. It's just it costs money. So some of them, like if you wanted to try to pay, let's say you did a 30-year mortgage, but you wanted to pay it off at the end of 15 years. Some penalties, it depends on the wording in the promissory note, but you have to pay all the interest that you wouldn't have paid. So it didn't save you anything.
Right.
Some of them, the penalty is a set fee. Some of them, it's a percentage of the interest they would have recouped. It just depends.
Does that happen with cars?
Not